Hello. So today we will see paper of March, March 2023 extended. So we'll start by solving the question number 1. This question is about gases found in clean dry air and gases found in polluted air. Name one gas found in clean dry air which contributes to global warming. Now here in the question they have clearly given a hint that it causes global warming. So the gas which will be present in clean dry air will be carbon dioxide. Next is state the percentage of nitrogen in clean dry air. We know that it is around 78%. Okay. Name the substance used to remove sulfur dioxide in flue gas desulfurization. Desulfurization is to remove sulfur dioxide from fossil fuels. So we use calcium oxide. Nitrogen dioxide is formed in car engines. Name the equipment in a car exhaust used to remove the NO2 formed in car engines. So how do nitrogen oxides are removed? So they are removed in catalytic converter by reduction of nitrogen oxides to nitrogen gas. Next is all gas diffuses. Choose from the list of formulae the gas which diffuse most quickly. Draw a circle around your answer. From the given options, first of all, we have to find out the molar mass of all these given options, and then we have to see which is having the lowest molar mass. So here methane is having the lowest molar mass because of which it will diffuse quickly and fast. So the reason will be it is having a lowest relative molecular mass. State one adverse effect of carbon monoxide on human health. So carbon monoxide is toxic in nature. It combines with the hemoglobin. Okay, that is why it is toxic in nature. Carbon dioxide is a reactant in photosynthesis. So we know the two main products produced in photosynthesis are glucose and oxygen. Complete the dot and cross diagram for a molecule of CO. Show outer shell electrons only. Now here, the cross is represented as electron of carbon and dot is represented as electron of oxygen. Here, carbon are having 4 electrons in the outer shell. It needs 4 more electrons to complete the outer shell with 8 electrons. So, it will give 2 electrons to each carbon. Okay, and the oxygen have 6 electrons in its outer shell. It needs 2 more electrons. So oxygen will share that 2 electrons with carbon. So each oxygen will share 2 electrons with carbon, and in the outer shell of oxygen, when 2 electrons are shared, 4 will be remaining. So this is how you draw the structure covalent compound carbon dioxide. Lithium, sodium, and potassium are group 1 elements. Name the type of bonding in these elements. We know that lithium, sodium, and potassium are known as alkali metals. As they are metals, they will be having metallic bonding. Sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. State the test for hydrogen gas. So the test is lighted splint. The splint will relight again and the result will be a squeaky pop sound. Suggest the pH of a solution of a strong alkali. Now it is a strong alkali, that is why the pH will be 14. Name a substance which can be used to confirm the pH of a solution of a strong alkali. So here we will use universal indicator. It helps to know the pH, specific pH of any acid or base. Write the symbolic equation for the reaction between sodium and cold water. Include state symbols. So here we have to also include the state symbols. So I will start writing. In the question, they have clearly given you have to react sodium with cold water. So we will write the symbol of sodium, that is Na plus H2O gives us Na2O, NaOH, plus H2. Okay. Now we have to balance the equation here. Here you can see we are having total 2 hydrogens, 2 plus 1, that is 3 hydrogens. Whereas here we are having only 2 hydrogens. That is why we are writing 2 here. So it becomes 2 twos are 4 hydrogens. Here we are having one oxygen. When we are writing it 2 on left hand side, that becomes 2 oxygen. That is why we write 2 in front of NaOH. Now as sodium becomes 2, we have to write 2 in front of sodium on reactant side. Talking about state symbols, sodium, which will be a metal, that is why it is in solid state. Water always comes in a liquid state, that is why it is written L. Sodium hydroxide, it is in aqueous state, so we will write AQ, and hydrogen is a gas, that is why we will write G. Next, lithium has two naturally occurring types of atoms, 6Li and 7Li. State the name given to atoms of same elements with different nucleon numbers. So, here you can see 6Li and 7Li, where 6 and 7 are the nucleon number of lithium. Those who are having different nucleon numbers are known as isotopes. In the table, they have given to find out protons, neutrons, and electrons of 6Li and 7Li plus. By using periodic table, we can write down the proton number of lithium is 3 in both the cases. For finding electrons, we will subtract 3 minus the 6 minus the proton number. So 6 minus 3 gives us 3. And here 7 minus 3 gives us 4. Next, for electrons. In this case, protons are equal to electrons. That is why, as lithium is not carrying any kind of charge, we have same number of electrons, that is 3. But here in case of 7Li, lithium is carrying a positive charge. It means one electron is donated. That is why we will subtract one electron from protons. That is 3 minus 1 is equal to 2. So we have 2 electrons here. Next is we have to find out the relative atomic mass of lithium to 1 decimal place. What we are going to do is multiplying the nucleon number with the percentage relative abundance. So 6 multiplied by 10 plus 7 multiplied by 90. We get 690, which we are going to divide by 100 as we want the percent. So it is 6.9. So the relative atomic mass of lithium becomes 6.9. Next, potassium oxide, K2O, is an ionic compound. It shows the electronic configuration of ions in potassium oxide. Show the changes on the charges on the ions. Now, they have given the ionic compound K2O and its structure with its electronic configuration. Here, as potassium is having one electron in its outermost shell, it donates that one electron to oxygen, because of which it will gain a positive charge, +1 charge. So on both the potassium, we are having a +1 charge. In case of oxygen, only one shell is drawn. We have to draw the other shell where there are 6 electrons of oxygen itself, and 1 electron each is gained from each potassium. That is why it gains a -2, that is -2 charge. The Haber's process is used to manufacture ammonia. State the main source of each gas used in Haber's process. So nitrogen is gained from air and hydrogen is gained from hydrocarbons. That is why we have written methane. The reaction is reversible. The forward reaction is exothermic. Here they have given us the reaction of, that is, N2 plus 3H2, which reversibly gives 2NH3. State what is meant by the symbol delta H. So delta means something where there is a change, and H is heat, right? So heat is known as enthalpy. That is why it is known as enthalpy change. Delta H for the forward reaction is minus 92 kilojoules per mole. State why this value shows that the forward reaction is exothermic, because the delta H is having a negative sign, because of which it shows that it is an exothermic reaction. Here they have asked to write the conditions involved in Haber's process. So the temperature we use is 450 degrees Celsius. Pressure used here is 20,000 kilopascals, and catalyst used is iron. Complete the table to show the effect if and when the typical condition in the Haber's process are changed. Use only the words increase, decrease, or no change. So by using these words, we have to fill this table. Now, first is temperature increases. Now, effect on the rate of forward reaction. Here they have given it increases. Here they have asked in the context of rate of reaction. So if we increase the temperature, rate of reaction will increase. In this second column, they have asked about effect on concentration in terms of equilibrium. So N2 plus 3H2 gives 2NH3. The forward reaction here is exothermic, because of which if we are increasing the temperature, it will favor the endothermic reaction, the backward reaction. That is why the amount of the yield of ammonia will decrease. So we will write here decreases. Pressure decreases. When we decrease the pressure, the rate of reaction decreases as the particles move away from each other, are far away from each other. In terms of equilibrium, when the pressure decreases, the equilibrium shifts to the side where there are more number of gas moles or gas molecules. In this case, we have 3H2, and in front of nitrogen, no number is written, no stoichiometric coefficient is written, because of which we will consider it 1. So 3 plus 1 gives 4, and here we are having 2 moles of ammonia. So when pressure is increased, it shifts towards the side where there are more number of molecules, so it will shift towards the side of reactants, because of which again the yield of ammonia decreases. So we will write decrease. In case of catalyst, when there is no catalyst, the rate of reaction will of course decrease, and because of the presence of catalyst, there is no effect on equilibrium, because of which we will write no change. Explain in terms of collision theory why increasing the temperature increases the rate of reaction. Here they have clearly mentioned that you have to write in terms of collision theory. So no need to write in the form in the terms of equilibrium or whether the yield will increase or decrease. Okay, you have to write in the form of collision theory. So as we will increase the temperature, the particles will gain more kinetic energy. This will lead to an increase in the frequency of their collision, as the particles are having greater energy than the activation energy. So these 3 points must be included to gain 3 marks. Ammonia reacts with an acid to form ammonium sulfate, NH4 twice SO4. State the formula of the acid used. Here you can see we are having sulfate in the formula. That is why the acid which would be used for making ammonium sulfate will be sulfuric acid. State one use of ammonium sulfate. So ammonium sulfate is used as fertilizer. Calculate the percentage composition by mass of nitrogen in ammonium sulfate. So first of all, we will find out the molar mass of ammonium sulfate. We will add the atomic masses of nitrogen, hydrogen, sulfur and oxygen. So we will get the molar mass 132. As we have to find percentage by mass of nitrogen, we have to see how many nitrogen atoms are there in this formula. So we have 2 nitrogen atoms here. So 2 into molar mass of nitrogen, that is 14, which equals to 28. So 28 divided by 132 multiplied by 100, as we have to find out percentage, which will give us 21.2% of nitrogen is present in ammonium sulfate. Copper is element 29th in the periodic table. Brass contains copper. Now brass is an alloy, so it is made up of copper and zinc. State the term given to a mixture of a metal with another element. So mixture of metals is known as alloy. Copper can be stretched into wires. Copper wires conduct electricity. Name the property of metals, which means that they can be stretched into wires, which is known as ductility. When metals can be drawn into wires, they are known as ductile, and when they can be converted into sheets, they are known as malleable. Name the particles responsible for the conduction of electricity in solid copper. So electrons are responsible for conducting electricity in metals. Copper is a transition element. Some physical and chemical properties of transition elements are shown. Here they have already given two physical and two chemical properties of transition elements. In the question they are asking state one other physical property of transition elements. So other than which is stated here, we have to write a different physical property. So we can write high melting point here. And in case of another chemical property, colored compounds and variable oxidation number is given. So we can write they act as a catalyst. Hydrated copper sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules present in hydrated crystals. So when water is a part of any salt structure, it is known as water of crystallization. State the color of hydrated copper sulfate crystals. So copper sulfate is blue in color. Formula for hydrated copper sulfate is CuSO4.5H2O. So there are 5 moles of water present in what? Copper sulfate. Copper 2 oxide is formed when copper 2 nitrate is heated. So when copper nitrate is heated, we get copper oxide, nitrogen dioxide and oxygen. State the class of oxide to which copper oxide belongs. As copper is a metal, when metals combine with oxygen, they form basic oxides. So it is basic in nature. It is a basic oxide. State the meaning of Roman numeral 2 in the name copper 2 oxide. In case of transition elements, as we have seen just now, they have variable oxidation number, because of which the Roman numerals indicate the oxidation number in the compound. So here for copper it is +2. 0.200 moles of copper nitrate is heated. Calculate the mass of 0.0200 moles of copper nitrate. First of all, we have to find out the molar mass of copper nitrate. By adding all the atomic masses, we get the total 188. In this case, the formula of moles is equal to given mass upon molar mass. As moles is given and molar mass is given, we have to find out the mass. So we will multiply moles into molar mass, which will give us 3.76 grams. We have to calculate the total volume of gas in dm cube at RTP, that is room temperature and pressure, produced when 0.0200 moles of copper nitrate is heated. In this case, they have highlighted the word, they have written the word bold, total in bold, right? So the total gas, we have to first look at the equation here. We have two gases, nitrogen dioxide and oxygen. There are 4 moles of nitrogen dioxide and 1 mole of oxygen. So in total that is 4 plus 1, that is 5 moles of gas produced on decomposition of copper nitrate. So here 0.0200 into 5 divided by, in the question we are having 2 moles of copper nitrate. So divided by 2, which will give us 0.05 moles. Now, moles of gases are found by the formula moles is equal to volume upon 24. So as we have to find out volume, we have moles of gases and 24. So we will multiply 0.05 into 24, which will give us 1.2 dm cube as the volume. Next is powdered aluminium reduces copper to oxide. Write the symbol equation for this reaction. As we know that aluminium is more reactive than copper oxide, we will write Al, symbol of aluminium, plus copper oxide CuO, which will give us Al2O3 plus 3Cu. As we are having 2 aluminium here, we will write 2 on the reactant side. We have 3 oxygen here on the product side, so we will write 3 in front of copper oxide, which becomes 3 copper, and because of which we will write 3 on product side. Hence it will balance the equation. Now, these questions are about organic chemistry. So propane, propene, propane 1-ol and propanoic acid are members of different homologous series. Molecules of these substances can contain 3 carbon atoms. Explain why members of homologous series have similar chemical properties. So one of its reason is as they have same functional group, because of which they have similar chemical properties. Name the homologous series to which propanoic acid belongs. So propanoic acid belongs to carboxylic acid. We understand this from its naming point of view. So it is named, so you can see the ending of propanoic acid is OIC, oic acid. Carboxylic acids are named in the ending as oic acid. State the general formula of homologous series to which propanoic acid belongs. So it is CnH2n plus 1 COOH. Next we have propane 1-ol has an unbranched isomer. Name the isomer, which is propane 2-ol. We will just shift the OH functional group to the second carbon. We have to draw the structure. So as it is propane, so we have to draw 3 carbon atoms. We have to satisfy its valency using the hydrogen, and on the second carbon atom we have to put OH functional group. So this is the unbranched isomer of propane 1-ol. Propane and propene can be manufactured by heating decane C10H22 in the presence of catalyst. One other product is formed. Complete the equation for this reaction. So we have C10H22. This reaction is known as cracking. Here we will get 1 alkane and 2 alkenes. So we have C3H8 propane, C3H4 propene and C4H8 butene. Name this process, manufacturing process. So this is known as cracking. Propene forms a polymer named polypropene. Draw the displayed formula of a section of polypropene showing 3 repeat units. So here we know that propene has 3 carbon atoms and there will be a double bond, but as we have to draw a structure of polymer, so there will be no double bond here. Okay, so here it will be C single bond C, and we have to write it CH3 here, and we will show the different displayed. We will show the displayed formula here by showing all the bonds of carbon and hydrogen. As it is a polymer, so it is in continuation, so we will draw an extended bonds on both the ends of the carbon. State the type of State the type of polymerization that occurs when propene forms polypropene. So such kind of structure is formed, or such kind of polymer is formed by addition reaction. Propanoic acid reacts with aqueous sodium carbonate to form a salt. Suggest the name of salt form. So as we are having propanoic acid and it is reacting with sodium carbonate, we will get sodium propanoate. The structure of its anion is CH3CH2COO minus. So here after CO we have Na. So Na will be plus, it will have a positive charge, and this is the negative anion. Propanoic acid forms an ester when it reacts with ethanol in presence of a catalyst. Suggest a suitable catalyst. You can write acid, and if you know the name, you can write phosphoric acid. If you don't know the name, simply write acid. Name the ester formed. Now propanoic acid, when it will react with ethanol, it will give us ethyl propanoate. Always we have to write the name of the alcohol involved first. So here, as ethanol is used, we will write ethyl here first, and then we will write propanoate. Esters naming ends as OATE, OATE. So the structure is CH3 CH2 C double bond O CH2 CH3. This CH2 CH3, it comes from ethanol, and this is the part of propanoic acid. Thank you.